My name is Barry. I'm one of the co-founders of Skip. My other co-founder is right over here, Magnus. I'm going to talk to you about sovereign MEV today and what Skip is and what we do. We are a Series A startup, by the way, and we're hiring for anyone who is not yet convinced in what they're hacking on.
Great team.
So we build sovereign MEV infrastructure and protocols. And for us, in the modular stack, in the sovereign L1 stack, that means basically giving protocols the ability to do two really important things. One is help them control what kinds of MEV can and can't be extracted. So a classic example of this is almost all the validators, almost all the protocols in Cosmos that we work with don't want to facilitate front-running or sandwich attacks because they are net negative for user experience, but they are very excited to facilitate back-running style MEV because that's something that doesn't actually harm the price that their users are executing it against. So they want to be able to facilitate certain kinds of things and prevent other kinds of things that they view as more net extractive. And then the second super important thing is control who and which stakers actually profit the most off of MEV. So in Ethereum, the way PBS works is it's just sort of this massive subsidy system for the proposers. But in the modular stack and the sovereign stack, people have MEV wrapped into the story and the go-to-market and the unique value proposition of their chain. So we work with chains who want to see MEV actually go back to LPs because they view it as something that harms LPs. We work with chains who want to see it go back to validators. We work with other chains who want to see it actually go back to the developers who are building on their chain. So that's sort of Canto's approach, that's Archway's approach, all of these ideas around contract secured revenue. And then we work with others who just want to see users recapture their own MEV as their end goal. And so giving them the ability to do these two kinds of things is sort of how we define sovereign MEV and what we use as our North Star. So we provide two styles of solutions right now, in-protocol solutions. So we build this thing called ProtoRev for Osmosis that I'm going to talk to you guys about, and then extra protocol solutions. So off-chain block space auctioning systems, which we call Skip Select, which we deploy to Evmos, Juno, Terra2, Injective, and a number of other Cosmos chains. So Skip Select first is basically a very customizable top-of-block auction system for primarily Tendermint and IBC blockchains. So the way it works is we run from infrastructure that we call the Sentinel that captures a bunch of bundled trades from searchers who are trying to capture mostly liquidations, mostly back-running opportunities. And then we have a bunch of low latency stuff that simulates those transactions, tries to find bundles that we can put on chain together that are complementary, tries to find which ones conflict, and then constructs the most profitable top of block that we can for a validator and for a protocol according to some preferences that they have. So validators decide, okay, do I want to facilitate front running and sandwiching? Do I not? Do I want to keep MEV for myself? Do I want to give it back to my stakers? Do I want to give it back to the network? And how much of the block is Skip responsible for building? So unlike the system that does some of this work in Ethereum, we don't build the whole block, right? We build a portion of the block that is configurable by the chain and by the community so that we don't actually become, and nobody who builds the block can become a vector of censorship from something like OFAC. There's a collaborative block building process that happens. So this is deployed in a bunch of different places on Cosmos, running on several hundred validators at this point, processing tens of thousands of transactions a day. The second thing that we do is called ProtoRev, which is fully in protocol. So this takes advantage, much more so than Skip Select does, of the kinds of very unique things you can do when you decide exactly how you want different kinds of transactions to function in your VM when you have something like a Cosmos SDK or an OP stack blockchain, something you can only build in the modular stack. Basically, the high-level way it works is it in-houses all MEV recapture that is possible just on Osmosis. On-chain, basically doing back-running calculations after the execution of every transaction on Osmosis. And it does this at no cost of capital. It flash mints and flash burns tokens natively. And it's fully open source, right? So like it was built in partnership with the Osmosis community, in partnership with their developers there. And it runs on each validator as a part of consensus. So there is nothing that anyone in the Cosmos ecosystem, or in the Osmosis ecosystem, including us now, can do to actually undermine this kind of MEV recapture system. And it's fully controlled by governance. So high-level graphic for how this works. You have a transaction, comes into the DEX, potentially imbalances prices. You have a solver that runs, sees, okay, is there free money to be made by rebalancing those prices, and then flash mints and flash burns tokens to do that. And then it redirects all of that revenue back to the community. So instead of this leaking out to searchers or more likely to infrastructure providers that those searchers are using to win latency wars, it goes to Osmosis. So this kind of solution in its current form is not generalizable, right? It's very, very specific to how the Osmosis DEX works and very specific to the kinds of transactions they have. But the long-term goal is to have sovereign solutions that enable full block building control by the protocol without any kinds of off-chain actors, including skip, and have those be transparent and open source and enforceable by consensus in the same way ProtoRev is, and compatible with cross-chain MEV extraction, right? So how can we maintain a lot of these properties that we've achieved with our very specific custom system, but build something or a set of solutions that are more generalizable to a host of other things that folks might want to accomplish and build in the modular ecosystem. So this is some inside baseball on Tendermint, which I don't know how much anybody actually knows about, but I'm going to talk about it, and maybe you'll learn something. So Tendermint is a consensus algorithm that's beneath Celestia, as well as all of these different Cosmos chains, and it's in many other places as well. It's in Polygon. They use a fork of Tendermint. The Binance governance chain uses a fork of Tendermint. Tendermint's sort of like this godfather consensus algorithm that's in a bunch of places. And the way Tendermint interacts with the application code on top of it, the actual like blockchain state machine, is through this thing called ABCI, which is the application blockchain interface. It's like exactly what it says it is. And the way it works right now is Tendermint builds the whole block, comes to consensus on the block, does all of the work of consensus, and Tendermint doesn't know jack shit about what transactions actually mean or what the application actually wants to accomplish. So it just sees like bytes that are flying around. And that's nice for scaling and generalizability, but it's shitty for MEV, because what that means is any kind of off-chain random actor can come in, reorder transactions, insert new things, do whatever the hell you might want, and there's no way for a sovereign app or roll-up developer to do anything about it. So ABCI++ is where this is going. I think they couldn't think of a great name for the next generation of this system, but the ++ is supposed to capture that this is much, much better. And it is, especially from an MEV perspective, because what's changing is that the application is becoming very intelligent about actually its own block building process. So what you're going to see is instead of Tendermint coming to consensus and then just giving the application a block transaction by transaction, the application actually dictates how Tendermint votes on a block. So there's a process by which Tendermint asks the blockchain, hey, what transaction should I put in my block? And then code written by rollup or application developers in Tendermint or on Rollkit or any other ABCI++ aware SDK can replace those transactions, add new ones, shuffle them around, do whatever, and then return that to Tendermint. And then Tendermint gives that to all the other validators. And those validators ask the application again, hey, I got this block. How should I vote on it? And so what this means is the mempool in many ways, which is just sort of like this thing that controls MEV and has been like sort of attached to the consensus algorithm for so long and is in most chains, is becoming something the application can be opinionated about, which is going to give application developers the ability to be very opinionated about how MEV works and potentially realize more of this vision of sovereign MEV. That kind of makes sense. Those very like specific and technical, but I think a lot of the ideas generalize to things that we want to see in lots of other formats in the modular stack. But our goal, something that we're working on a lot right now, is trying to, like I said before, generalize ProtoRev into this broader concept of having protocol-owned builders where application developers can make decisions about how MEV actually works on their chain. So we're building the first version of this right now as basically an auction that validators can run, where you have new kinds of transactions that are like meta transactions, where searchers can bundle in the same way that they can bundle using Skip's off-chain infrastructure. Validators can simulate things in the same way that Skip does so in our off-chain infrastructure, and in the same way that we maintain reputation systems about users interacting with our block building infrastructure. We're going to give validators all of the same tools and protocols, all of the same tools to do that. So we think there are a lot of kind of downsides of off-chain systems, even though we've built one that works very well today. The big thing is like builder centralization. So like Skip builds basically all of the blocks for a lot of different chains in Cosmos right now, and like that's nice for us, we like that, but it's probably not good for decentralization, even though we have that collaborative block building process. And it's not really incentive compatible, right? So there is no reason, people trust us, I think, because we generally are good actors and have shipped products that have helped the Cosmos ecosystem and all of these sovereign app developers make a lot of money off their MEV and prevent the kinds of MEV they want to prevent. But like in practice, we could just rug that system, right? Because it is so centralized and so off-chain. And so opaque, like people don't really know what our infrastructure does. And we could censor transactions in theory. And systems like PBS sort of claim to solve this and in some ways work towards solving it. But in practice, you are seeing in Ethereum that like there are relayers that stand out as being responsible for most of the blocks that get included in Ethereum right now. And some of those relayers are OFAC compliant, for example. And this is like a big problem in Ethereum right now. So Ethereum is like slowly beginning to think through some of these questions about how can we put more interesting kinds of MEV-aware logic and build MEV-aware applications on chain. But because the EVM is so mature and because it secures tens and tens of billions of dollars of capital right now, their ability to experiment with this and their ability to move forward with this is quite slow. But we think that we can build protocol-owned builders that fix a lot of these problems and make meaningful improvements over off-chain systems and still help chains achieve sort of this goal of sovereign MEV. We can sort of make validators into much more intelligent builders themselves. We can, using consensus and rules in the protocol, enforce resistance to off-chain agreements between validators and particular searchers. And we can have all of this be open sourced, and auditable by the community, editable by application developers. We're starting to do this now. Osmosis is going to be our first design partner for this in-protocol auction system that I've been talking about. And we're going to be leveraging a lot of this cool stuff from ABCI++ to make it so that proposers can't just undermine the whole thing and take the money for themselves. This V0 of what we're building, like I was saying, is going to introduce some cool new things. This on-chain bundle type of transaction, the ability to actually have a single pay, single winner auction on-chain, which is not something that Ethereum or other ecosystems have been able to accomplish. In these sort of old days of MEV, pre-Flashbots, pre-PBS, you had mempool gas wars where all of the losers still ended up with reverted transactions on-chain. And we're able to actually fix that problem using the Sovereign toolkit. And then we're going to be using these things called vote extensions, which I won't get into a ton of detail on, but basically allow the network to have some additional data to audit some of the decisions that are made by a proposer. So what that means is we can make these auctions more credible. So a proposer can say, oh, hey, this was like the highest paying bid, but actually like it was some shit bid, but they just took a bunch of money from someone off chain. We can actually make that much, much harder to do. And then you're still going to have very useful off-chain actors around searchers and more advanced simulators. But we can give this toolkit to chains. And we're going to have the first version of this launching sometime, I think, in the next 4 months is the goal. But the idea here, right, to back up a little bit, talk about like why we think this is important in the first place, is that there is a feedback loop that we've identified in Cosmos that drives a lot of the development there, that I think is going to drive a lot of the development in the broader modular ecosystem as well, which is very important, which is this idea that there is a sort of mutually beneficial and reinforcing relationship between the core devs of a protocol, the users of that protocol, and the various sort of off-chain, on-chain, centralized entities that secure it. In Cosmos, right, this is just validators. But in the modular stack, this also gets a little bit more complicated. You have provers and sequencers and validators maybe, and sometimes you have all of them, and maybe you don't have any of them. But this idea that those kinds of actors have very frequently reputation and participate in social consensus and give feedback to chain founders and sort of act as the voice of the users in like a sort of meta competition that's happening between all of these different L1s and modular protocols, creates a very nice feedback loop. But that feedback loop only works when you can actually implement the new kinds of features and feedback that you're getting on-chain, when the application developers actually have the ability to be responsive to it and can't just get rugged by off-chain MEV extractors and profit-maximizing proposers who go unchecked. So we are trying to move this sort of black box process of what happens between when a user signs a transaction and how a bunch of transactions get put into a block more on-chain, or at least make it more accessible to protocol developers to govern, audit, control, and improve. So that's kind of what Skip is all about. It's sort of what we're working on right now. I think that's the end of the talk. Oh, yes, like I said, we're hiring. We're Series A right now, hiring for developers, researchers, and ops roles. So, pick your poison. But we'll be around afterwards if you guys want to chat with us. That's it. That's all I got.
All right, we have 2 minutes per question. If you have any questions for Barry, go for it.
Yeah, I had a question about like skip select in particular. Like, I know like Cosmos is like first in, first out, sort of like traditionally that's the way like sequencing is done. Like, do validators need to run like a separate software now just for skip select, or is that?
It's a good question.
Yeah.
We have a modified version of Tendermint that they run that it is aware of our auction, basically. Right. So we send them bundles of transactions. They also get stuff out of the mempool. Bundles go first, mempool stuff go second, is the simple explanation. And the mempool is still first come, first serve.
Quick question, follow-up. Is it social consensus that, like, how do you enforce that? Like, this goes first, this goes second, like, how do they pick it apart?
So there is a combination of we police validators to ensure that they're actually building the blocks that we're expecting them to build, and social consensus. So like something like chains are now sort of opting to upgrade to MEV Tendermint on a chain-wide basis because they want this system, because it actually now, like on Juno, it was unprofitable to run a validator 2 months ago, and now because of MEV recapture, validators are able to actually pay their infrastructure bills, which is kind of cool. But yeah.
All righty. Thanks,
Cool.
Barry.
Yeah, thanks, Yas.